necessarily. If a wire's laying on the ground energized, you won't see it. You won't hear it in a lot of cases, but it can be laying on the ground energized, either back feed from a generator, or because the fault current is so low, or the wire's just hanging in the air freely and isn't touching anything that will blow a fuse. It's really a dangerous situation until Duke people get there and say that it's okay. And I'll even go a step further to say Duke people, because a lot of times our firefighters and stuff are used to looking at things and they've seen it for years and years, and they will think that because they've seen this over and over that wire's laying on the ground, it has to be de-energized. Okay? But just please wait for a Duke person to tell you that it's okay to proceed and go on into an area before you start helping folks, because just to try to help them before it's time can actually get you injured, and and like I say, up including death with this stuff. I mean, it'll sometimes kill you before your eyes are closed. So one of the last things we're going to demonstrate, and Dean can get out of those hot clothes, is we just got this everyday ordinary wiener here, all right? And the reason we use this is because this gives us a pretty good look into what happens if we get electrocuted as a human. Now, obviously, we can't get any volunteers to walk up and be the sacrificial lamb for today, or the martyr here, but when the test that we use to know that this is similar to us is an ohms test. We've talked about voltage today a little bit about amps, but ohms is nothing more than resistance, okay? And when we take an ohms meter, we could check anybody that's here today if you're relatively healthy with a normal amount of moisture in your body, and you'll measure about 900 ohms of resistance. That's whether you're a baby or an adult, whether you're a man or a woman, tall, short, skinny, fat, doesn't matter. Okay? When we check this hot dog, it measures about 775 to 800 ohms of resistance. So it shows us it's a pretty good shot of what it'll look like. Now, the first thing that Gene's going to do with this is what we call a brush contact. A brush contact with electricity is where you just come in contact with it for a second. Your hand just brushes it or you touch it, and it lets you move. Okay, and then we'll do a sustained contact, which is if you become electrocuted and you become unconscious and you're laying on it and you can't get loose and you're just laying there, and it's a really bad thing at that point. But what I want you to do first, we're going to do a brush contact, and what I'd like for you to try to notice is the fire that is trying to get out the end of that hot dog. Okay? Just a fierce amount of heat and fire that's associated with that in just a short amount of time, with just a brush contact. That's all it takes right there. 7,200 volts straight through your body, and you would expect that hot dog to explode or burn up or anything. There's not that much going on with it. It does go in, because with every electrocution you have an entrance wound and an exit wound. And I'll show you that in just a second, and we'll talk about some of the things that it does to you medically. But
Don't do that, I'm getting hungry.
you don't want that one anymore. That one's setting up an infection already. I'll show you that too. But what he's going to do is do a little more of a sustained contact. I mean, you could just let it cook and cook, but by that time, there's nothing that anybody could have done for you. But the funny thing about this is that you would expect, because of all that, you would expect to see a lot more damage. There just isn't. And that's true with us too. You'll have an entrance wound where it comes in, you'll have an exit wound where it goes out. Now, if this was shaped like a pretzel, it's always going to take the straightest path. It's always going to take electric to take the quickest path to ground, always. And that's going to be, you do the pole. It takes the quickest path to ground, and that's what he's going to demonstrate for us next. Is we've got a piece of pipe laying there, and that's going to be a ladder on a fire truck. That's going to be a ladder in your garage. It can be a pressure washer wand. It could be scaffolding that you've got set up. It could be anything that you can reach or come in contact with our power lines with. But one of the things that I always ask at these demonstrations is that people will always tell us that, or I'll just ask you to let's say that pipe right there is 7,200 volts, okay? And let's just say that I go over here, for whatever reason I would decide to do this, which is a terrible idea, but if I started to do this, and this is 7,200 volts, do I have to touch that to get electrocuted, or do you think that I'll get kind of close to it, it'll jump out and get me?
Jump out.
Okay? We hear that. He says it'll jump out and get you. It absolutely will not. Okay? Now, I know what you're thinking, like with a spark plug or sometimes, but that spark plug electricity is really not electric. It's a frequency. That's a little bit different. Okay? But with true electricity, it's lazy. It'll take the quickest and most efficient path. Now, what he's going to show you is that right now, when I turn this on, the light bulb will be on. It'll be just a normal day in Independence, okay? And what he's got that pole resting on is a solid neutral. So it's a great connection to ground. And he's going to move that pipe towards that 7,200 volt phase. And if he could stop that within a playing card or a baseball card distance from that wire, absolutely nothing will happen. So it will not. However, when he touches it and goes to pull it away, you'll notice the little bit of lightning and fire that's chasing it. It changes it. It's game on at that point, okay, once you do touch it. But make no mistake about it, you have to come in contact with it to get injured, okay, or for it to act. Now, check this out. This is kind of neat to see. He gets as close as he can to it and still nothing. Light bulb is on. It has no idea that we're there. But then when he touches it, the light bulb goes out because now the quickest path is through that pipe. Even though electric can travel 186,000 miles a second, it has no interest in going out and lighting that bulb. Starting to have too much fun with that, wasn't it?
Do it again.
But that's the truth, folks. That doesn't mean that I told you at the beginning 10 feet to stay away from it, when then he just told me I have to touch it to get hurt. Well, 10 feet is just the safety buffer, okay? You want to stay 10 feet away from it at all times. But the truth of the matter is, you have to touch it. Now, the higher the voltage, the farther that flash will be when he pulls the pipe away. And almost 100% of the time when we go out and we see somebody that's operating a crane or something that's an aerial device, and we go out and we investigate it after they hit it, more often than not they'll say, I didn't touch it. We just got close to it and it jumped over. Well, the reason they think that is because nobody intentionally has their boom in the air and moves that into the wire. But when they're doing something else and they hit it, they hear it, they look up. They may be this far from the wire now, and it's running back and forth and it's melting the tires off the truck or burning holes in the ground or whatever, depending on the voltage. But they don't think they ever touched it. And actually they hit it and moved on through it, and it's still barking at them. It's still talking back. So, but if they went up there and they just got close to it and didn't touch it, it wouldn't have happened. So they think they're telling us the truth, when in essence we know better. We know that you had to hit it to do it. But and along with that, if you're ever on a piece of equipment that becomes energized, or you have an automobile accident, you hit a pole and the wires land on the car, the safest place for you is to stay on that equipment or stay in the car. But if you have to get out of the car because it's on fire, or you smell gasoline and you think it's going to blow, or whatever, the only safe way to get out of that car is open the car door or stand on the side of that equipment and jump off. Okay? And the way I describe that is, if you've ever seen 1,000 birds up on a power line, they go up there 1,000 at a time. They're sitting there on that wire. They're energized at whatever the voltage is on that wire. They have no idea because they're only on one wire. So whenever they're ready, they fly away. That would be us. Okay? Touch one, you're all right. If by chance, though, the bird has a wingspan that can reach across two wires, or the wood cross-arm brace on the pole or anything, then you've got a reference to ground, or you've got a difference in potential. That's where you get in trouble. So again, if there's a wire down on a car, or you're in a bulldozer or a backhoe or something, and you you dig something up and it's energized, the only way to get off of that safely is to jump. Okay? Jump away or jump out of the car. Can't tar in the ground at the same time, or you become like the squirrel did. Okay? Totally different then. One thing we'll talk about is, let's say that this wire here is laying on the ground and it's 7,200 volts. Okay? There's something in electricity called concentric circles. Okay? And to describe that easily, it's like if you throw a rock into a pond. Where it goes in, it splashes, and then you see all those little circles go out, and they get weaker and weaker until there's nothing left. Exactly what electricity is doing on the ground. It may be 7,200 volts here, but 10 feet away, 0 volts. However, if you were standing right here and it was energized, you couldn't just walk away, because if you step into a different circle, there's a difference in potential there, because this is 7,200 volts. It might be 5,000 right here. Well, if you step from here to here, there's a 2,000 volt difference in potential going right through here, right in and right out. If you were going to stand here and move away, the only chance you would have is to shuffle your feet so you stay in the same concentric circle all the time, or you could hop, jump from one to another, because like the bird, as you leave it and enter it, you would be